Integration by parts state that the integral of u dv equals uv minus the integral of v du. Sometimes we might have to use substitution and then integration by parts. For example, evaluate the indefinite integral x cubed the square root of 4 plus x squared dx. We will run into an issue if we were to let u equals 4 plus x squared and use substitution. And so we'll try integration by parts. If we let u be either x cubed or the square root of 4 plus x squared, the expression will get messier. And so we're going to find a way to rewrite it by first letting u be 4 plus x squared with the purpose of substitution, not integration by part yet. Then du is 2x dx. There is a factor of x in x cubed, so we will save a factor x dx for the substitution 1/2 du. That is, we rewrite the integral x cubed the square root of 4 plus x squared dx as the integral of x squared the square root of 4 plus x squared x dx. Again, we save one copy of x because the du is 2x dx. We end up with the integral of x squared times the square root of u times 1/2 du, because x dx is 1/2 du. Some might not be happy with this expression because the variable of integration is now u, but there's x squared in it. We need to find a way to rewrite x squared in terms of u. But the relationship between u and x is that u equals 4 minus x squared. Therefore, x squared is u minus 4. The substitution for x squared is now u minus 4. The square root of u can be rewritten at u to the 1/2. The factor 1/2 can be moved to the front of the integral sign, du. This is 1/2 the integral. We distribute u to the 1/2 to obtain u to the 3/2 minus 4 u to the 1/2 du. This integral can be easily evaluated using the power rule. The antiderivative of u to the 1/2 is u to the 5/2 at 1 to 3/2. The antiderivative of u to the 1/2 is u to the 3/2. We no longer have the integral signs, so we add a constant k. Distribute the 1/2, we have 1/5 u to the 5/2 minus, distribute the 1/2, we have 4/3 u to the 3/2 plus a constant k. But this is not the final answer. There is no u in the given integral. There's only x. The substitution with u equals 4 plus x squared. Therefore, we substitute u with 4 plus x squared. 1/5 the square root of 4 plus x squared to the 5th power minus 4/3 the square root of 4 plus x squared to the 3rd power. And this is the final answer, and so we will change the capital K to an arbitrary constant c. For an alternative answer, We find the common denominator, which is 15. We factor out u to the 3/2. What remains in the factor is 3u. Notice that 1 over 15 times 3 is 1 over 5, and u 3/2 times u is u to the 5/2 minus 20, because the common denominator is 15. 20 over 15 is 4 over 3. We then replace u with 4 plus x squared. We replace u with 4 plus x squared. The answer is 1 over 15, 4 plus x squared, 3/2, times 3 times 4 is 12. 12 minus 20 is minus 8. 3x squared minus 8. And we simply use c for an arbitrary constant.